Today I will be talking about sensuous design and algorithmic thinking, and we will be hovering our conversation with these 4 words. Actually, we will be extracting what does that mean. You can check out our works from www.sensoryorbit.com and we can kickstart. So when we say sensuous design and algorithmic thinking, actually we can cross-reference these as sensuous thinking and algorithmic design, and they're all correlated with each other. But the sensuous design and algorithmic thinking process is what's really core value of our work. I'm an architect, but not just an architect that has an intersection with art, architecture, science, and engineering. And we believe that the future, and especially today, not only future, is in that direction that, of course, you have your specializations, but you cannot disregard different disciplines while you're doing that. And this sensuous design algorithmic thinking is our base when we are in our creative process. So I will speak about an abstraction of a creative process in our daily routine, in our architecture and design studio, Sensory. The creative process starts with asking key questions during the process of creation that leads to success to create various sensories. So we are aiming to create sensories by asking key questions, and that is leading to the design process. And these questions can find their answers in every scale, including graphic design, product design, furniture design, architectural design, urban design, and virtual reality design. And that's all what we are interested in. There's no scale. There's every scale of the work that we're interested. If we were to abstract a design process, so this is when an idea comes. Everything is blurred. There's nothing concrete. Everything is possibilities. And then in the process, there are some moments that are helping you to become in that refinement. So from this blur, at least you know that there's something going on. There's something is shaping in your mind. And if there were something that you could call as design molecules, we would abstract them as these. And they would slowly create a form. They would slowly help you to create a formal, solid something. And then if you were able to see yourself from outside, and if you would be able to zoom out to yourself, you would see that that design process would create an aura around you, that you get excited, that you're in the process, you feel the molecules, you feel everything. And then there are some things that starts to have some shape. You feel the roots, you feel that how this form in your mind starts to get evolved. And then as a person, again, as a designer, you are all affected by this magnetic area that this process creates. And then your design has its form, it's arised from its roots, and then it's ready. When say ready, that we can call the process becomes the artwork itself. And this is one of the projects that was that I was explaining with the visuals that we have done in Istanbul. It's actually the region's largest 3D printed installation, Taxon, and it's a 4-meter tall exoskeleton prototype that has been designed completely parametrically and algorithmically. So there's a certain specific code that has been developed to be able to create different design variations. And the aim of this project is to question how would be the future of the structural elements if we could 3D print them. And I need to correct myself, because when I say could, don't think that we are not able to, because the technology that we have right now is enabling us to 3D print these forms. But it's not that common yet to be budget friendly, let's say, in the most friendly way. But it doesn't mean that we are not able to test them in different scales. So this is a small prototype, as you can see, 3D printed small prototype, and then you will see the large built 3D printed installation. that can accommodate one person inside of it. The form has been designed to have some porosity that is also allowing structural integrity. And this is a scale that we are working on. So when we go back to the design itself, design process and everything, there are inputs and outputs. And inputs in the design process and design everything is the human and the machine. So as a person, you're a human and you're involved, but you're involved with your machines, right? And as a description, human sensories, 5 different senses are making you a human in the most common way. The adjective sensory describes something related to sensation, something that you feel with your physical senses. And machine is, what's related with machines is the algorithms, which is a set of mathematical instructions that must be followed in a fixed order, and that, especially if given to a computer, will help to calculate an answer to a mathematical problem. And then when we combine them, it becomes human and machine collaboration that is creating the process, the design process itself. And in the human and machine collaboration, we're talking about design as a verb. And design is to intend a result. You're intending a result. And through that design process, you need to think. And thinking is the activity of using your mind to consider something. And the output of this process becomes sensuous design and algorithmic thinking. So the topic of this presentation is what we are covering right now, because we explained the sensory, human sensories, the design aspect that you're intending a result, algorithms, which is the machinic aspect, and thinking is the way that you are using your mind. And we are interested in these 4 words, how they are creating innovative projects. And we are working and thinking in multi-scale. Generative art is one of the scales that we are working. So we are very enjoying to test our ideas in different scales. As I explained in the beginning of the presentation, it could be architecture, virtual design, furniture design, graphic design. And these studies that we have done are, for example, exploring a potential second skin that humans can adapt that are affecting in the different moods. These are some urban studies that are having real-time data. This is a typography project that we have developed that has been currently commissioned by a private gallery, and that is exploring the dynamic typography techniques to create a completely algorithmically designed new fonts, let's say, through the elliptic design. And we call the project Tentacle because it has been inspired by the tentacles of the animals. We are working with data and how we're visualizing, but also adapting those data into the form, but not only in 2D, but also in 3D. And we are also, again, some data projects that we have done to create unique landscapes. And for us, every kind of design needs to be very dynamic. So together with the generative art, for us, the parametric design is very important, and we are always looking new ways to integrate the new technologies to the architecture and construction industry. And to be able to do that, we need to get inspired from nature. For example, this project has been inspired by the crystal formations in nature, and then we adapted them into a column design. And there was a famous question and also statement that ornament is crime in the modernist era. And now we're asking, is ornament still a crime? Because we can create very algorithmically designed ornaments that are very unique, but also with the new ways of construction, as we are more capable to construct them, we might go further and investigate those forms. So for us, parametric formal studies are very important for us to integrate them whenever we need to do that. This is a project that we have developed for a project in Lisbon, for example. There are 3D printed bricks. They are mimicking the sponge formations, coral formations, inspired by their behaviors in nature, but they're and they're lightweight. By having this geometry and then using geometry as the source of input, we can create 3D printed bricks like that. This is another parametric architecture element that we have developed, which is a dynamic facade panel that is that, as we call, breathing through the climate data. And other scale that we're working is architecture. And architecture for us is a passion. For me, it's a passion. And we are always looking for new ways to integrate new ideas. This has been, this is a project that we have done with my two colleagues, Mariana Custodio dos Santos and Juan Carlos Naranjo. This is a project in Nevada, USA, for Elon Musk's visionary Hyperloop desert campus. And we have been awarded as finalists. And this project aims to have different loops, different ways of integrating with the building, and the symbiosis between the rough landscape and the iconic technology is creating this form. And there's this integrated design system that brings 4 types of building together, each having unique features. And the reminiscence of indestructibility and resilience found in the landform are very, very inspirational for us. And there are 4 different courtyards that are introducing water elements in the desert environment of Nevada that are creating oasis-like environments. And the building's design spirals up, and then the people are able to walk on it, that we believe that there's no end and there's no beginning of the building. And interior is also quite dynamic. The campus consolidates the high-tech identity, and there is also an interior relationship with the Hyperloop tubes itself. And this has been our kind of one of the architecture projects. And recently, you could also see it from our website, www.sensoryorbit.com. Again, that we have recently won a RIBA trophy from Royal Institute of British Architects with our project in China. So to kind of summarize, algorithmic thinking is enabling the way to explore cross-scale dynamics that can be also found in nature and the universe. Cross-scale dynamics are giving the freedom to designers and consumers to recontextualize concepts. Having the workflow of Sensuous design, algorithmic thinking is the core value of sensory and Paddle Labs to physicalize the virtuality and to virtualize the physicality. We need to learn how to design with machines, to be able to live with the machines. And from this blurred visions, from this blurred moments, hope we are all getting this. And this stage is very important, this transition, because all the creative minds are able to step one step forward from this. But if you don't feed your creativity, then your creativity would be stopped in here, which we don't aim. And we believe to be creative, you just need to get inspired, and that's all. And thank you for listening. If you want to reach me, you can always reach me from this email and through the Creative Community Network. Thank you all for listening.
So it looks like we have a question in the chat.
Yes. So I will read out loud the question. Do you think a machine will be able to ever have the senses to come up with the ideas to design, process, and produce them? I think the machine will come up with ideas, design, process, and produce them, yes. But the senses are a bit complicated because the human sensories are like sight, as different things, but the human mind works in a different way, that we are kind of those sensories are blending your creativity. And to get creative as a human, you don't need to have any kind of other knowledge, but for a machine, they would need to go through a different data sets. Of course, we also have some different data sets that are our subconsciousness, for example, the movies that we watch, the touristic visits that we have done. But our creativity is not limited with that. You define algorithmic in the traditional sense. New big data algorithms process data to infer models, sort of patterns. Can you comment on data sets you use? Sure. Every discipline has a different way of using algorithms. I mean, every single thing that we're using as a software is using an algorithm. So I think we don't need to kind of overcomplicate it in a way that I'm just talking about the general knowledge of the algorithm, that so for some people it's perceived as something like unreachable or like something very not with the machines. We need to talk their language. For example, robotic construction processes, we are using C# programs to be able to, but for other algorithms, for example, for creative coding, we use Java programming and then processing as a tool, and we are able to kind of adapt different kind of thing. And in our workflow, in our architectural softwares, sometimes we are writing custom Python scripts to be able to kind of integrate those algorithms to the architectural design. Because for us, the parametric design is about creating the variety. So imagine we are in the architectural design process and we are designing a building. We need to be able to optimize that process. For example, we have a meeting with our engineer, and our engineer tells us that we need to kind of increase our column width, and that's 3D model that we have need to be parametrically, algorithmically modeled to be able for us to manipulate and adapt it. Because otherwise you would go back, because before it was working like that. Because before it was like architects were designing from almost scratch, most of it, and the technical drawings were made from scratch. But with us currently, with the current technologies, that to be able to optimize those processes are for us very optimizing workflows, let's say.